I'm going to talk about question number 12. Question number 12 is the one problem, and this was requested by Mr. Marsh, because for AP Physics, the one thing he kind of covers, or he's going to do a lot more with angles, or Mr. Linton. But this is one thing that it's worth being able to do a little bit. This is the one example where our normal force will not be equal to the weight. So this is one example, like normally we say, all right, weight pushes down, and we're going to make normal force pushing back up, and they're equal, and that means we can use friction is equal to mu mg. But that's not really the formula. Really, if we can do this, and we've been doing this, but really the formula is friction is equal to mu times the normal force. It just so happens that we've been saying the normal force is equal to mass times gravity. All right? Now, so going over here, if something's pulling at an angle, some of that force is going to help pull horizontally, and some of that force is going to help pull vertically. The vertical piece is going to be what subtracts away the weight, just like we showed with the football player pushing up. So the first thing we need to do is figure out what is the normal force going to be. Once we know what the normal force is, then we can use it to figure out the friction down below. Okay? So first thing is this. We're going to say that the normal force is equal to gravity pushing down minus the vertical piece pushing up. Okay, so we have gravity pulling straight down, and then minus the force applied, but only the force applied going up and down, which I would use the letter Y. You could also just say vertical. Okay, so force in the Y direction, or you could say vertical here, whatever you want to say. So that would mean force, the normal force would be equal to mass times gravity minus force applied times the vertical piece. Remember when we did components and SOHCAHTOA and all that stuff? We said anything vertical would be sine theta. So this would be force applied FA times sine theta. All right? Or mass 13 times 9.8 minus my force applied is 91.1, 91.1 times sine of 64 degrees. So if you plug that in, I get the normal force. What the floor is going to push back up with is 45.5 newtons. Okay? Now, if we looked in the horizontal piece, so now we did only horizontal, we would again say net force is equal to, what's happening? The net force is equal to. We're going to pull, right, the force applied, but it's only going to be the horizontal piece of it. So that would be force applied in the x direction. Or again, I don't care if you write x or just say horizontal or whatever, but it's going to be the horizontal piece of the force we're pulling with. And then friction's got to fight again against us, and that's going to be mu times the normal force. And we just found out the normal force up here. Okay? Now, then I put my equations underneath. I have MA. I have force applied times cosine theta, because now we're doing the horizontal piece. And in physics, the horizontal piece is always cosine. Minus, and then that's going to be, again, mu times the normal force, which we already calculated. It's not mg, it's that. All right, then we plug in underneath. So 13 times A. My force applied is 91.1. Cosine 64 degrees minus mu, whoops, I'm sorry, 0.35 times 45.5. Okay? Yes, this is far beyond what, this is a bigger step. Don't laugh at me about it. This is a bigger step. Am I expecting that you can master the heavy-duty calculations of it? I'm not expecting that you can master it. I'm having you work your way through it for this problem for Utexas because it's very important to try to work it through. Am I going to test you on doing calculations like this? No. Am I going to, could I ask you, hey, does it take more, is it more friction if you push down like a lawnmower or pull at an angle like a sled? Yeah. We've talked about that, how the normal force can change. But that's how you're going to do that problem.